Good afternoon. This is Joshua, and if you don't see my screen, please tell us somehow. And just to briefly summarize how we're going to present this, I'll introduce myself and briefly Michael and our topic for today. Then I'll hand over to Michael, who will continue to introduce himself and then talk on the high level about our theme, about how you isolate tenant architectures for SaaS in general. And we'll take a question or two very briefly after that, maybe 5 minutes. And then I will present more specifically on SageMaker inference endpoints. So going into more detail on that theme, going deep into that area, machine learning software as a service. Like Michael and I, who have worked together in various companies, wrote this article, which you can read on the Amazon Partner Network blog about implementing software as a service, tenant isolation using SageMaker endpoints and IAM. And this talk is related to that article, but of course it's not the same. It includes a much broader perspective, and hopefully we'll clarify some of these ideas, which get pretty detailed. Now I'm going to hand over to Michael, please.
Hi, everyone. I'm Michael Pelts. I'm a senior solutions architect in AWS. I'm working with large organizations in Israel and EMEA, helping them to build SaaS products on AWS. SaaS and ML are my favorite topics, and I'm happy to talk about them today with you. So let me share my screen. All right, so our topic today is tenant isolation in SaaS applications. We will be using SageMaker endpoints as an example, but the underlying ideas are relevant for any SaaS application that you build. Before we dive into SageMaker, a few words about why we want to isolate tenants, when and how. So the tenant isolation is basically a security requirement. The goal is to prevent one tenant from accessing data that belongs to another tenant. And as any other security topic, you would typically want to have multiple levels of defense. And we will see what it means to tenant isolation. Besides security, there are additional drivers that influence your isolation strategy. Isolation might be imposed by compliance requirements, especially in highly regulated industry, such as banking, for example. Isolation is helpful when you want to deal with noisy neighbors. Tiering strategy might be helpful as well in tenant isolation. This way you can give priority to higher tiers. And legacy architecture. For example, a monolith application, it basically suggests all or nothing approach to tenant isolation. With microservices, you can implement isolation for individual components. Let's review 3 common tenant isolation models. And the first one is called Silo. Silo is all about dedicated resources. That means that each individual tenant gets a separate stack of resources. This applies to compute and storage. For example, a tenant might get a dedicated EC2 instance or dedicated database. The second isolation model is called pool, and it's about shared resources. Means that multiple tenants can make use of the same compute component like EC2, Lambda, container, as well as the same database. For example, they can share data in the same cluster, same database. And the last one is bridge. Bridge is a mix of shared and isolated resources, usually in a more complex architecture that contains multiple components. In reality, most applications is a mix of pool and silo. As you see on the screen, in this case, we have got two dedicated microservices, one shared database. Here we have both compute and storage in the pool mode. Here we've got microservice in the pool mode, dedicated databases, siloed queues. So you can see here different variations, and for each component in your architecture, you decide what would be the right isolation model. Let's discuss the siloed architecture in more detail. So in the center of the siloed architecture, there are tenant dedicated infrastructure stacks. Each stack is automatically provisioned at tenant onboarding time and used only by this particular tenant. Big part of SaaS architecture is these blue boxes on the screen. These are shared services. They are essential for your ability to operate services efficiently. Shared services is sort of control plane for your application. And tenant isolation doesn't apply to them, as they don't usually manage tenant data. There are many different types of shared services that you typically find almost in any SaaS application: onboarding, provisioning, identity, and so on. Each of them deserves a separate session. We will not get into it today. But they are critical. And let me explain why. So you're probably familiar with this architecture, which is currently on the screen, when you have multiple single tenant application. This is not a SaaS. This is not software as a service. It's actually pretty common anti-pattern. This approach quickly leads to different versions of software deployed for different tenants. The result is lack of uniformity, and it's a huge pain to manage. The solution is to run the same software for all tenants and manage tenant stacks by shared services. The key takeaway here is that shared services provide unified experience and thus reduce complexity. This is what makes your whole architecture more manageable. Let's get back to the tenant isolation. As with any security, as with any type of security, you typically want multiple levels of defense. Here at the top, you see application enforced policies. This is about your application logic that prevents cross-tenant access. It can be your own code or open source libraries like OPA, Open Policy Agent. This is a brilliant piece of software that I would recommend to take a look. It has nothing to do with AWS, but quite helpful for application level security. And all right, now you have got your application level security, and all is good as long as your code behaves as expected. But you typically don't want to assume well-defined code, well-behaved well-behaved code. That means that application level isolation alone is not enough. Next to layers in this stack of isolation layers in Silo are network-based and identity-based isolation. They define guardrails, or they together define flexibility boundaries for your application level policies. Network isolation is pretty straightforward. What is not accessible is usually more secure, right? And identity-based isolation relies on IAM policies to protect access to tenant resources. Application enforced policies are part of application code. They are often part of routing or configuration logic. For example, you can configure routing to point to tenant-specific components, or you can use configuration to connect to a tenant-specific database. But what happens if you try to cross tenant boundaries in your application? For example, you connect to a database that belongs to another tenant. That could be a result of an error in your code or malicious activity. That would be really bad if you could do that, right? And isolation at network and identity levels help you to prevent that. So on this slide, as you see, isolation policy at application level is everywhere, is between compute components and between compute components and database. As I mentioned, you achieve that by routing and by configuration and by things like OPA. Now let's talk about network isolation strategies. There are many different flavors of network isolation. We'll talk about just 3 of them. So the first is a kind of extreme one, account per tenant. It's the most restrictive one as it combines between network isolation and IAM isolation, because each account comes with its own set of roles and policies, right? The next one is VPC per tenant. Resources live in different VPCs, and they are simply not addressable until you do something special like VPC peering or start using transit gateway. And the last one is subnet per tenant. Means that just at the network setup of your VPC, you define or use security rules and routing to isolate tenants into dedicated subnets. IAM-based isolation for Silo is pretty straightforward. Here we have got Lambda per tenant. Same Lambda code is used for all functions, but with different execution roles for each function. Execution roles ensure that a Lambda provisioned for tenant A can only access tenant A database. You just create a policy like that. So policy for Lambda for tenant 1 allows access, let's say, to a bucket with specific prefixes for this particular tenant. And you have multiple policies like that, each attached to corresponding Lambda. As a result, cross-tenant access will be denied by IAM policies, by infrastructure level. So if you combine application level isolation with infrastructure level isolation, you basically leverage both layers to protect your tenants. And for some reason, something goes wrong with application level protection, identity level protection will help you. Now let's review the pooled architecture. The big difference compared to silo is that we use here one shared stack of resources for all tenants. The web app here receives requests from multiple tenants. Microservices serve all tenants and databases, and all databases contain data for all tenants. In this architecture, there is no need to provision a new infrastructure at tenant onboarding time. New tenants use existing infrastructure. And as for shared services, well, nothing new here, same blue boxes. Their responsibility might be slightly different compared to silo. For example, provisioning doesn't provision a dedicated stack of resources per tenant, but it's still there because quite often you have to provision something like policies, IAM policies, for example. But in general, the same shared services, you have them here as well. Quite obviously, there is no network level isolation in this architecture because the components are shared, right? That makes IAM-based isolation even more important for the pool model. In the pool architecture, each request is executed in security context of a particular tenant. For each request, a dedicated access context is created dynamically. Here we have got a shared Lambda and a shared S3 bucket with tenant-specific prefixes. How do we ensure that Lambda cannot access other tenants' objects than S3? Here is how it works. The IAM role that you attach to a Lambda, the execution role, doesn't allow the Lambda itself to access S3. But it does allow Lambda temporarily assume other tenant-specific roles with scoped permissions to a particular prefix in S3. This is technically achieved by calling assume role function of STS. Assume role returns temporary credentials that are then used to securely access tenant-specific prefixes in a shared bucket. And as a result, you effectively restrict cross-tenant access at runtime, dynamically.
So this is Joshua taking over. I'm a senior cloud architect at DoiT International. And just as Michael is an architect at AWS. And Michael presented tenant isolation on a high level. I'm going to drill down into tenant isolation for machine learning as a service with SageMaker endpoints, going over the same silo pool bridge concept, but perhaps giving you a more detailed implementation idea of how we do it. No, we need to keep them separate on the infrastructure as well as the application level. So as Michael said, you write your code, you keep it secure, but you want to make sure that you lock it down also on the level of the cloud provider's services, the infrastructure. And the people you're protecting from are, first of all, outsiders, the hackers, and secondly, other tenants who are authorized to use the system, but they're not authorized to see data from tenants other than themselves, and maybe employees too. But in each case, grant least privilege possible to a user. A user should only be able to do what they need to do to get their job done, and no more. Well, you can open up more privilege and you won't see any harm, because if they don't use a certain feature, what happens? But of course, that's where security breaches happen. And inferencing could have sensitive data. Inferencing means prediction. It means asking the machine learning model a question about some of these examples I'll give. And it can have some very sensitive data. Is Mary Amin likely to have cancer is part of your input. It's a question you're asking. How much debt is Ali Smith able to take on? That is very sensitive. And who should Werner McGuire date next? I chose these because they're classic examples for machine learning. And just as the input can be sensitive, so can the output. Just asking if she has cancer is sensitive, but knowing that she does, oh my goodness. Just asking if Ali can take on debt says that Ali is asking for a loan, but knowing how much says how much money they have and so on. And knowing that Werner is about to go date Patricia is super sensitive. Now you might say that this information does not go as part of an inferencing request, because an actual inferencing request is all numbers. It doesn't say Mary, it doesn't say Werner, and it just has some internal identifier, you might say. But in fact, this is sensitive. First of all, you might put the identifiers in the input for debugging, for tracing. I can easily see that you would put the people's names or their personal identifiers in the request, just to keep track of things. And, or conversely in the output, if you ask, which people are likely to be my potential customers, the output could have identifiers for those people. But even if it does not, it is so easy to de-identify. If you know somebody's zip code, its postal code, their age, their gender, then you can easily identify the exact person. You can go find articles on the internet. It's like magic. So there are no secrets in this type of data. And there's some even more abstruse examples. For example, what if you're trying to identify a person here, and you see that there's overfitting for this one person? Overfitting may mean that the model was trained on that person, and so it really, really knows that person. And so now you've figured out that that person was in the training set. Membership inference attack. The model can similarly memorize information you did not think it was memorizing. For example, a generative sequence text model, like the famous ones recently that have been producing entire stories based on very short prompts, do so by reading millions and billions of bytes of text and then finding the most common patterns. Well, of course, that's a very simplistic way of saying it. Now, in general, they don't just spit back exactly what they read, but to some statistical extent, yes, they're just spitting back what they read. They've memorized the training data. And the model itself can be extracted by inference. The model is, of course, a collection of weights. Behind the scenes, it is what we use for the prediction. And even if that does not leak, inference can tell us enough input-output can tell us the weights in the model. So there's some scientific papers here. All this is to say that machine learning information is sensitive. The architecture here is on the right. Let's start on the far right-hand side of the screen, even though it's like the end of the request, the model. That's output from your training. That has the brains of your machine learning. It sits in S3, and to expose it, use a SageMaker endpoint. That's a virtual machine that they spin up for you. They manage, they can create new copies for scaling, and it has an API. However, no one calls that API. The endpoint is not intended for being called by an application. Instead, you have a Lambda that has a lot of the logic, the application layer logic. And in a minute, we'll see what we mean by that in the area we're talking about, which is authorization. So the invocation is done through a Lambda. It translates your code to the machine learning layer completely managed by Amazon. And then a gateway is needed to expose this to the internet. And then way off on the left, we have the tenant who is making the invocation and asking for an inference. Let's talk about silo. Yes, there's a grain silo, tall, vertical, a lot of grain, and with no windows. it is closed. This is a nothing shared architecture. Each tenant, as you see on the bottom of the screen, each tenant has these components: API gateway. You could share it, but that's not silo. We'll get into that in a minute. The silo is a pure example, but as Michael said, they're typically mixed. Lambda function is not shared. Each one has their own. But as Michael said, it is the same code. Same code. Everything is just a copy. And everyone has their own role, which, of course, is only allowed to access their tenant. Each one has their own endpoint that just exposes this one model. For tenant 1, they have their own endpoint. Tenant 2 has their own endpoint. And of course, each one has their own model. The model is the crown jewels. That has the logic from this marketing company, this medical company. To allow access only to the tenant, we have what you see on the very top of the screen, tenant 1 Lambda execution role. That means the Lambda has this role, it has this permission to access the endpoint according to the policy, which is only for that tenant. And you certify, you authorize that only the tenant 1 can access this stack using JWT tokens. That's part of a standard login procedure that they might do in the browser, or an application might do it. We will not get into that now, but it's very standard nowadays that when someone logs in, they get this little JSON piece of secret information that has been signed and certified that tenant 1 is accessing the Lambda, and that's how we know who it is. That is the silo. Everything here is one-to-one. The Lambda execution role is one-to-one with the SageMaker policy, invoke endpoint policy, which is one-to-one with the endpoint. Very simple. And the policy is simple too. As you see here, there are no variables. Well, of course, you see region account ID, but that's not a variable when you deploy it. And it just says tenant 1 is the only one who's allowed to access this endpoint, as you see in the lower right of the screen. This is authorizing invoke endpoint. That is the action. The resource is an endpoint. There are advantages, giving us specifics as to what Michael said earlier. It's very simple. You just generate a new execution role. Each tenant knows that other tenants are not stepping on their feet. If one tenant is making a zillion calls per minute, the other tenant does not have to worry that the resources are overburdened. Limited blast radius means that if something crashes, it only crashes there for that tenant. Very sad, but only for that tenant. And compliance regulations may just require this. It may not even be up for discussion, but in any case, it's secure because you know that things are completely separated from each other. It's also easy to meet your costs because each tenant pays for their own stack. Either they pay or you pay, but you can internally budget it to that tenant. Disadvantages are that it gets expensive. You're copying everything for every tenant. Also, as you make more and more roles, you can run into quotas built into AWS, and you just can't make any more. Onboarding is difficult because you have to create a new resource, a new complete stack of resources for every tenant. Of course, you do that with a script using infrastructure as code, CloudFormation, Terraform, but still, you have to do it. And it's a type of complexity because you have so many resources, so many lambdas, so many endpoints, some disadvantages. Let's talk about the pool, which is the opposite. In the pool, everything is shared. In the silo, of course, the code base, of course, the structure, as Michael said, is absolutely a copy of each other. But here, the actual resources are shared. Everyone accesses the same gateway. They access the same lambda, the same endpoint, which exposes multiple models. The models, however, are not shared. The models, in fact, in the end, are just files in S3. And we have to talk about how this is kept secure. So if everybody has the same role, how do we even tell them apart? This is done using assume role, using the tenant ID. Now I'll show you the exact policy, but first let's discuss assume role. This means that the Lambda has its own execution role all the time. But when a tenant request comes in order that the Lambda can access the endpoint, it takes up a special role using the tenant ID. It assumes the role using the tenant ID. So there is this identifier that is going to be inside the role, and we are going to authorize based on that identifier. I'll show you in a moment how that works. So that's the key security step, that the Lambda, in assuming the role, gets a temporary security credential just for this. STS is the service that gives these security credentials. You see there's a clock icon, meaning that it only lasts a very short time, and in fact only for the time of this request. This is called attribute-based access control, contrasting RBAC, role-based access control. You know about RBAC. That is the basic IAM concept that you've learned, roles, policies. With ABAC, we look at specific facts about the request, in our case, the tenant ID. And based on that, we allow access. That's very dynamic, in contrast to RBAC, which is defined before the fact. You can dynamically generate new IAM policies all the time. You could completely generate a new policy, a new RBAC policy for every tenant, but we're not talking about that. We're talking about ABAC, and let's see how that works. I'm going to first look at this JSON and then go back to how it's used. As you see here, there's a variable. This is a real variable, which is used at runtime. It has the $, and unlike what we saw before, the tenant ID is replaced in the request. tar_gz indicates that in the end, we're talking about a model. We're restricting access to tenant 1 model, tenant 2 model. It's the same endpoint. We're not restricting access to that. But because the different models have different names, their files have different names based, of course, on the tenant, we can dynamically, using the variable, restrict access. Again, to go back to this diagram, because this is really at the heart of our technical point, and that is a new thing that you may be learning technically about ABAC. The tenant 1 makes a request to the Lambda. The Lambda gets a temporary session just for the moment that has a tag on it. You see the icon of a tag. Of course, the tag is tenant 1. We get to the endpoint, and now the ABAC authorization checks the name of the file, tenant1.tar.gz, does it match the tag? If so, we allow authorization. So this ABAC concept enables pooling resources, which is much cheaper. You don't hit quotas. There's no onboarding, really? Well, you might, of course, have to add a new tenant, but you don't have to onboard new resources. You don't have to launch a new endpoint, a new Lambda. And in that way, it's simple to manage. It may be complicated to understand the concept of ABAC, but it's easy to manage because you have so few resources running, so few Lambdas and so on. The disadvantages of everything, of course, is the opposite of silo that you heard earlier. Cold start, noisy neighbors. That means that if your neighbors are bombarding the system, the other tenants are bombarding the system, then the scaling must launch a new endpoint instance, a new virtual machine, so that's slow. And all the invocations are in the same Lambda. The laws might not allow that, and you, as developer, have to write code with no global variables, because that would leak. And if something goes down, everything goes down. So that was an easy summary of advantages. The disadvantage is really the opposite. But now I'm going to talk about the middle, the bridge. So here it's going to be a briefer presentation because you already know the key concepts, but we're combining silo and pool. Here you see that some things are shared and some are not shared. What is not shared is, of course, the model. That's one model is about marketing, the other is about health. Of course, they're different, but also the endpoint. On the other hand, everything to the left is shared. The Lambda is shared, and the API gateway is shared. So the tenants, when they log in, they get a JWT token after logging in, which identifies them. It, of course, includes a tenant ID, and that tenant ID is used to authorize them access to the endpoint, to their own endpoint. It's only theirs. So here in Bridge, the tenant tag matches the endpoint name, not the model name, as we saw earlier when we talked about pool. ABAC here, a temporary session says that it has a tag tenant1, which matches the name of the endpoint. As you see here, the endpoint has tenant1 as part of its ARN, as part of its identifier. And the JSON has a variable, the $, the curly brackets, but the variable, as you see, is part of an ARN, an identifier for an endpoint. Endpoint / and then the tag. We allow invoking the endpoint only if there's a match. Advantages here are similar to what we learned for silo or pool, of course, because it's a balance. There's less of an issue with noisy neighbor than endpoint. Endpoint is often the problem with noisy neighbors because it is a virtual machine and it has to start up perhaps slowly if other tenants are using all the resources of an endpoint. And likewise, the blast radius is smaller in the endpoint. It's simpler in that way, but on the other hand, there is some copying of lambdas, of API gateways. Similar to silo, there is some copying. The expense per tenant is intermediate. Endpoints can get expensive. Often they're the most expensive because you may need some serious VMs to serve inference. And the Lambda code must have no globals. It must be written very carefully to isolate the invocations. There is a new silo option, which is in preview now, called Serverless Inference. Earlier I said that endpoints are virtual machines. It can get expensive. There can be noisy neighbor. With serverless, you don't have to think about that. AWS gives you the compute for that endpoint. From your perspective, there's no virtual machine. And it has, however, the same access control concept. So everything we said still applies, other than the specifics involving the virtual machine resource, such as expense, cold start. Those issues may occur, but they're behind the scenes, and Amazon is supposed to take care of that. Now, in conclusion, you have 3 choices. And this is your first and most important takeaway: silo, pool, and bridge. Silo isolates everything. Everything is fast, secure, locked down for that one tenant. It's good for premium users. They pay a lot and it costs a lot. They get the best service. Pool is good for lower tiers because they share, and it has all the opposite characteristics of silo. It's suitable not only for those who pay less, but also more specifically those who use the service rarely. If somebody pings your system once a month, pool looks like the right solution for them. And then bridge is a balance between the two, of course. This is the key takeaway. Technically, the key takeaway is ABAC, attribute-based access control. And even if the details of assume role, of using the JWT and the identifier seem complicated, you can read our article, of course, and of course you can review that later. Conceptually, the point is that the tenant ID is used at runtime to identify and authorize the tenant. And now, we'd like to hand over for questions. Please be in touch. You have our emails here. You can find us, and we're delighted to discuss this. So over to you for questions, please.